Okay, go ahead and get that essential question written down. So there are a number of ways to use the unit circle. I'm going to show you how to do it a couple of different ways. You're going to pick what works best for you, all right? Right now what we're trying to do is connect a relationship between our 30-60-90s and our 45-45-90s and how they're used with the unit circle, okay? Once we've established that connection, I'm going to show you a shortcut on the unit circle. All right, and how I use it in a calculus, coming at it from the other end from the calculus context. Right now we're looking at it from the geometry perspective, okay? I know. Some people do like geometry. Yeah, that's not my favorite thing to teach. I don't use formulas for it, though. I just figure out the areas of each side and add them up. That's easier. There were parts of geometry I did enjoy teaching. I had some good lessons back in the day. I got it. You guys might. Okay. So, again, what we're trying to do is we're going to try to establish a relationship between our 30-60-90, our 45-45-90, and the unit circle. Okay? All right, so what we have going on here is we can actually, a unit circle, okay, so you can draw this with me on your little patch there, means that we've got a circle. That isn't a very good one, okay, whose radius is 1 unit long. So no matter where I draw that radius on the circle, it will be 1 unit long, okay? And we're going to use it to help us measure angles on the circle. So I could measure that angle on the circle. Okay. And I could, it's not drawn in the same direction as yours, but I could draw what we call a reference triangle in there. Okay. And I know that my reference triangle, that this is still the radius, right? So I'm going to use a generic R on it for right now. This here, since it's in the X direction, I'm going to call X. And this here, since it's in the Y direction, I'm going to call Y. So ultimately what I've created is a point X, comma, Y. Okay. All right, so what this is saying down here is that trig functions of an angle in standard position, for any angle in standard position with measure theta, okay, a point xy on its terminal side, and radius is equal to this, which is basically, isn't that just r squared equals x squared plus y squared? Isn't that the Pythagorean theorem? Okay. We can use the trig functions are as follows. All this is doing is setting up all the trig functions we already know. Okay, this is just putting it algebraically. Okay, so the sine, according to this triangle right here, using that angle down there is our theta. What's the sine of that triangle? Y over r. Good. What does that make the cosecant of that triangle? R over y. Good. What about the cosine of that triangle? X over r. Good. And the secant of that triangle? R over x. Excellent. And the tangent of that triangle? Good, which makes the cotangent x over y. So all we did was take what we've already known, we threw some different letters on it, and wrote them down. Okay? Are we ever probably going to think of them in terms of those letters? Yeah, probably not. Our brain is still going to go back to Sokotoa and his girlfriend, right? Okay. So there are some other things that we eventually put better names and make these a little prettier, but for our purposes today, these are called the trig identities. These are some of a very, very small portion of the trig identities, okay? We've already learned that that cosecant is the reciprocal of sine, right? So if I had cosecant, it's the same as 1 over sine. Secant is the reciprocal of cosine, so we would call that 1 over cosine. And then there's two, we call them the quotient identities, and again, they come up eventually later, but it helps to kind of know what they are for our unit circle stuff. It is the sine over the cosine, and the cotangent is the cosine over the sine. So what we're going to work on right now is learning how to do the unit circle just for the axes. Because the axes, unfortunately, we can't use the triangles for. The triangles don't work. Okay? So we're gonna work on the axes first. Okay? So, if this is not in your notes, make sure it's there. Is it there? Is it correct? It says cosine comma sine. All right. So all these points. Remember how we said that it was going to be a coordinate. Okay. So it's the x coordinate and the y coordinate. All those points, the x coordinate is considered the cosine value. Okay. And the y coordinate is considered the sine value. We'll prove that to ourselves here in just a second. Okay. So I know that this is 0 degrees or 360 degrees, right? How many degrees is on this right here? 90. And then how many on this one here? 180. And how many on this one right here? 270, and so on. And it's in the table, it's also broken into the radians, right? Which you probably should learn what those radians, where they are on the unit circle like that. Okay. So all I'm going to do is if it's in the x spot, I'm going to use, I know it's the cosine value. If it's in the y spot, I know it's the sine value. Okay? So the sine of 90 is that value right there. What's the sine of, I'm sorry, that's not 90, is it? The sine of 90 is that value right there. What's the sine of 90? Okay, do that in your calculator real quick so you believe me. All right? Type the sine of 90 in. What do you get? 1. So, do you understand? Do you agree that that my little coordinate trick is working here? Okay. I forgot to explain where I got those coordinates from, right? Yeah. So your unit circle is how many units out? What did we say back here? How big is the radius on the unit circle? 1. So I put this in the context of the unit circle. I am out 1, up 0 at that point. I am out 0, up 1 at this point. I'm out -1, up 0 at this point. I'm out 0 and down 1 at this point. Okay, so that's where I got those values from. I just counted out 1 in each direction. Okay? When I go to draw my unit circle, the first thing I do when I'm doing calculus problems is that. I draw that. Okay? All right, so the sine of 180. So the y value at 180 is what? 0. Perfect. All right. What about the sine of 270? What's the y value there? -1. Perfect. All right. What about the sine of 360 or 2 pi? 0. Good. All right. The cosine, it tells us, is the x value. All right. So the x value at 90 is what? 0. Good. All right. What about at 180? -1. What about at 270? 0. And at 360? 1. Perfect. And we read that right off of the chart. Okay? Or right off of the unit circle. All right. So we just wrote down a minute ago. Remember we wrote these down? I told you that the tangent is the sine divided by the cosine. That's another way to think about it, other than opposite and adjacent. Okay? So what I'm going to do is I'm going to take the sine value and divide it by the cosine value, and that's going to give me the tangent. So the sine is 1 and the cosine is 0. What does that make the tangent? Does not make it. Are we allowed to divide by 0? No, we write the word undefined so our paper doesn't explode. Right? Because if we divide by 0, our paper explodes. Don't try it. I don't want to start a fire. Okay? All right. All right. So, we're going to do, so this one would be the sine is 0, and we're dividing by -1. What does that one equal to? That one's okay to be 0, right? Because the 0's in the numerator. All right. The tangent of this one would be -1 over 0, which is undefined. Good. All right, and then the 0 divided by the 1 is 0. All right. What's the cosecant the reciprocal of? 1 over sine. So aren't I just going to flip all of those? Remember, there's always a 1 in the denominator. So 1 over 1 is just going to be what? 1. This one's going to be 1 over 0. So whenever we see the over 0, what do we write down? Undefined. I'm going to abbreviate a little bit. All right. What's negative 1 over 1? Still going to be negative 1 when I flip it. All right. 1 over 0 is going to be what? Undefined again. Okay. Here, I looked at my sine value and I flipped it.
What's the other one?
What do you mean? There's always a 1 in the denominator. Right? Always a 1 in the denominator. All right. Secant is the reciprocal of what? Cosine. So now I'm going to look at this row right here. All right. So I'm going to flip this 0. So 1 over 0 is what? Undefined. All right. What would the 180 be? Negative 1 again. What about the 270? I'm not going to write it down. We've written it down enough, right? It should be undefined. Okay, because it's 1 over 0. What about 360? 1. All right, and I apologize. There's words over the top of the bottom part of the table. All right, the cotangent could be one of two things. It's the cosine divided by the sine, or I could flip the tangent, couldn't I? Okay. It's kind of your choice. I'm going to look at the sine divided by the cosine. Okay. All right. So, sorry, the cosine divided by the sine. So my cosine is 0. My sine is 1. So what is this first? What is 90? 0. Good. All right. I've got the cosine is negative 1 and my sine is 0. So what's that one? That one's undefined. My cosine is 0, and my sine is negative 1, so that one equals 0. And then my my cosine is 1, my sine is 0, so this one is undefined. So for right now, for our purposes, because we're just learning this, if you hit one of these values, you can go back and use your chart. Eventually, are you going to have to memorize how to do it based on the coordinates? Yes. Okay, but we're getting there. We're taking baby steps into this. This is the first time you've seen this in Trig. Okay? All right. So, the next one. All right. You've got your unit circles, right? I want you to look at... So I'm going to go a couple slides. I don't know why this popped in there without. All right, look at the orange ring. Everybody looking at the orange ring? How we wrote some stuff in there, and I told you we'd talk about it tomorrow. All right, so in the orange ring, it tells you what sign everything is going to be. So I'm talking about the positive or negative sign, not the trig sign. Okay. So in the first quadrant, all trig is positive. Okay. In the second quadrant, only the sine and the cosecant are positive. Everything else is negative. So if I get a cosine in that quadrant, or I get a tangent in that quadrant, or a secant or a cosecant, or secant or a cotangent, those are all negative there. So I only put the positive one in the ring. Tangent and cotangent are positive in the third. Everything else is negative. Cosine and secant are positive in the fourth. Everything else is negative. So the way I remember that is by the first letter, right? All students for sine take for tangent, calculus for cosine. Okay? It's also a subliminal message, so I get you to sign up for next year's class. Okay? All right, I know registration's coming fast, right? So I want you to sign up for calc next year. All right, so all students take calculus. All right? And of course, the other one that's positive is its reciprocal. All right? Okay, so that's going to help us with these next few problems. All we have to do is state whether the function is positive, negative, 0, or undefined. Okay? So, the first thing I'm going to do is I need to figure out where this is. So I'm going to find its coterminal angle by adding 360, right? So that way I can figure out where it exactly is on the unit circle, because negative 135 is not on our unit circle. So when I add 360, it's the same as saying the sine of what? You have calculators if you need them. So it's negative 135 and positive 360. 225. All right, go to your unit circle. Okay. Find 225. Which quadrant is 225 in? Third. In the third quadrant, let's see what we were looking at. We were looking at sine. Sine in the third quadrant, is sine positive or negative? Negative. Negative. That's all I need to write down, is that it's negative. Done. Okay, you could write the word negative, I suppose, instead of the symbol. Okay. All right. I need to figure out which quadrant 405 is in. So I'm going to subtract. I'm going to choose to subtract 360, would put it on my unit circle. So it's really the same as the cosine of what? 45. All right, looking at the cosine of 45. So I'm looking for 45. Which quadrant is it in? First quadrant. What's the sine? What is cosine positive or negative in the first quadrant? Positive. You guys, there isn't a ton of work to write down with these, right? I expect to see the problem written, and most of the time there's maybe a little scribble and then the answer. Okay, and there's a lot of thinking and working going on in your head trying to manipulate the unit circle on these first few assignments. Okay? All right, the tangent of 315. Is 315 on your unit circle? Yeah, what quadrant is it in? Fourth quadrant. Okay, so is tangent positive or negative in the fourth quadrant? Negative. So we're just going to write a negative there. All right, cotangent of 2 pi, is that in a quadrant? 2 pi is on an axis, right? So if it's on an axis, that's where I want you to go back to your chart. Which one was it? It was the cotangent, right? What is the cotangent of 2 pi? What did we decide? We went through all that calculation and decided that this one is undefined. You're probably only going to see the 0 or undefined answer if it's one of the ones on the axes. Okay? All right. Let's do 2 more together, and then I'll have you do 2 on your own. So cosecant of pi over 4. Which quadrant is pi over 4 in? First quadrant. Good. Is cosecant positive or negative in the first quadrant? Positive. Good job. All right. Secant of 11 pi over 4. Is 11 pi over 4 on our unit circle? Do you see it? I see 11 pi over 6, but do we have 11 pi over 4? No. Okay. So I have to subtract 2 pi, right? But in over 4 world, what is 2 pi? 4 pi. Nope.
It's just pi.
It's not just pi. I have to make an equivalent fraction with a denominator of 4. What do I have to multiply by?
8 pi over 4.
There you go. 8 pi over 4. So I'm really looking at the secant of what? What's 11 pi minus 8 pi? 3 pi over 4. All right. On our unit circle, where is 3 pi over 4? Which quadrant? Second quadrant. Good. The secant of 3 pi over 4, is it positive or negative? Negative. Good. All right. I want you to try tangent of 90 and cotangent of negative 45. You might have to use the table. You might have to subtract or add from 360. All right. I'm going to give you about a minute at the most. I want you to think through both of those. All right, tangent of 90. Is that on where is that on the unit circle? It's on an axis, right? It's on the vertical top part of the y-axis. So when you looked at your chart, what did you read for the tangent of 90? Undefined. Good. All right. What about cotangent of 45? What do I have to add here?
360.
Add 360, so I really get the cotangent of what? 315, what quadrant is 315 in? It's in fourth quadrant, okay? And in the fourth quadrant, is cotangent positive or negative? Negative, good job. Okay? All right, that was a baby step. All right, now we're going to take this and apply this to our unit circle. All right, I'm going to actually erase all my ink on there. Okay, because we're going to flip back and forth to that a lot. So you need your unit circle in front of you. And I want you to notice there's 3 different color triangles and 3 different color lines. Okay, so we've color coded the unit circle. If you land on a blue line, what color triangle should you be using? Blue. That means that 30 degrees is your reference angle. Okay? If you land on a green line, what color triangle should you be using? Green. If you land on a red line, what color triangle should you be using? Pink, right? The red and the pink go together because there was no pink colored pencil and red colored cardstock didn't come in the package. Okay, so yeah, no, we're just going to go with pink and red, okay? All right, and then if it's a black line, you know you're going to use your table, okay, for right now. All right, so I want you to look for 150. Which quadrant is 150 in? It's in quadrant 2. In quadrant 2 is cosine positive or negative? Negative. So we're going to write that down right now. Write the sign first. So I'm going to overemphasize the sign. So I'm going to write the plus or the minus. You don't have to write the plus, but you do have to write the minus. Okay? All right, so we decided quadrant 2. Okay? We already decided it's negative. What color is the line? Blue. Blue. Okay, so I know that I have to go to the blue triangle. All right? And we were looking at cosine of the blue triangle. Cosine is the adjacent over the hypotenuse. So which one is what number's on my adjacent? Square root of 3, what number's on my hypotenuse? 2. So I'm going to write down square root of 3 over 2. Done. Did I write down a lot of work? Did I do a lot of work, though? I had to ask myself like 3 questions to get that problem done. So I did a lot of work even though I didn't write down a lot of work. Okay. Cosecant of 135. So what quadrant is 135 in? 2. Quadrant 2. Okay. In quadrant 2 is cosecant positive or negative? Positive. So I'm going to write down, even though it's not necessary, I'm going to write that down so that kind of checks it off the box. I've double checked the sign already. Okay. All right. 135, what color is it? Red or pink, right? So we're going to use the pink triangle. We're looking for cosecant. Cosecant is CHO, isn't it? So what's on your hypotenuse? Square root of 2. What's on your opposite? 1. So I'm going to do square root of 2 over 1. Okay, so I'm going to do square root of 2 over 1. And I could leave it like that, but you could also just write it as square root of 2. I wouldn't mark you wrong for leaving a 1 in the denominator. All right, let's look at 240. So, which quadrant is 240 in? Third quadrant, okay. In third quadrant is sign positive or negative? Negative, excellent. All right, so 240 negative, and we're here. What color is it? Green, so that means I'm using my green 60-degree triangle. 60 is my reference angle, okay? So sine is so. What is my opposite? Square root of 3. What is my hypotenuse? 2. So we've got square root of 3 over 2, and it's negative. Okay, let's look at the next one. All right. 5 pi over 6, it's the tangent. All right. So, which quadrant is 5 pi over 6 in? 2. Second quadrant. Okay, and second quadrant is tangent positive or negative? Negative. Good. All right. So, I'm going to the wrong slide. It was 5 pi. So we're looking at this one here. Let me erase my ink again. All right. So I'm looking right here. What color triangle am I going to go to? Blue, right? Blue is my reference triangle. Tangent is TOA. So what's my opposite in my blue triangle? 1. What's my adjacent in my blue triangle? Square root of 3. Good. All right. So I've got 1 over square root of 3. Are we allowed to leave it like that? Not typically. So we're going to go ahead and rationalize the denominator. So we get negative square root of 3 over what? 3. Okay. The next one, cotangent. Oh, cotangent of 5 pi over 4. All right. What is the... I don't think I have the right answer. Oh, 5 pi over 4. I'm going... This isn't the... So 5 pi over 4 is in which quadrant?
Third.
The third quadrant. In the third quadrant, is cotangent positive or negative? Positive. All right. Cotangent. Let's go to... I'm going to go back to my circle here. All right. So, what color triangle am I going to? Pink. All right. Cotangent is adjacent over opposite. So what's my adjacent? 1. What's my opposite? 1. So what's my answer to this thing? 1. Positive 1. All right. Let me see what we got left here. All right. I need to do that one with you. Okay. I'm going to do one more with you. And then we're going to look at... Then I'm going to have you do a couple on your own. Okay? Make sure you've got this. All right. Is 8 pi over 3 on your unit circle? No. So if it's not on your unit circle, what's the rule? What do we have to do? Add or subtract 2 pi, or add or subtract. You might want to put that a note out to yourself in the left-hand column. If not on unit circle. Because it's going to come up quite a bit on the worksheet you're getting. Okay? Or on the problems you're getting. If it's not on the unit circle, you need to add or subtract 2 pi or add or subtract 360. So you've just got one of your two things you got to write down in the left-hand column, right? All right. Remember, there's 3 worlds. Well, there's 4 worlds, but 3 worlds that we typically work in radians, right? There's the over 3 world, the over 4 world, and the over 6 world, isn't there? Okay, so if I'm gonna, let's do all of our 2 pi conversions. If I'm gonna in the over 3 world, what's 2 pi the same as? 6 pi over 3, right? In the over 4 world, what's 2 pi the same as? 8 pi over 3, and then the over 4 and the over 6 world, what's 2 pi the same as? 12. You should pretty much be able to just go to those, okay? So I'm going to use the over 3 world, aren't I? So I'm going to subtract 6 pi over 3 from that. So I really get that it's coterminal to the secant of what? 2 pi over 3. Good. All right. Let's look at 2 pi over 3. Which quadrant is 2 pi over 3 in? 2. Quadrant 2. Is secant positive or negative in quadrant 2? Negative. All right. I want you to look at the triangle. I'm not going to flip back this time. The triangle secant should be the hypotenuse and the adjacent, right? Which triangle are you using? What color? It should be green, shouldn't it? Okay. So it should be the 60-degree reference triangle. What is the hypotenuse of that triangle? 2. What's the adjacent in that triangle? 1. So my answer to this one is just negative 2. All right, there are 3 more there. I'll get it. There are 3 more. I want you to try the other 3. Okay? So take a minute, a couple minutes, and try the other 3 problems. All right? Yes. Why do we have what? So the green overweighs the blue. Outdoes the blue. So it's just the green. Pretend it's just a green line. Because when we were drawing the 30s to mark, I said mark every 30, and it just made sense to draw the blue. There is a relationship between the two. Okay? Just use the green. Always use the green. Okay? Yeah. Why don't you sit down and watch the lesson and then go, since you're late. I'm almost done. Okay? I'll give you about 30 more seconds to try those 3. All right, let's check them. So 315, which quadrant is it in? Fourth quadrant. Positive or negative in the fourth? Negative. Good. All right. What color triangle are you going to use? The red or the pink triangle. Okay. Cotangent is the adjacent over the opposite. So what's your adjacent leg? 1. What's your opposite leg? 1. So -1 would be my answer on that one. All right. 2 pi over 3, which quadrant is it in? Second quadrant. Secant, positive or negative in the second quadrant? Negative. All right. Which color triangle for 2 pi over 3? Green. All right. And we're doing sha. So what's your hypotenuse? 2. And your adjacent? 1. So -2 should be the answer. Okay. All right. 11 is 11 pi over 6 on your unit circle? What quadrant? 4. Is cosine positive or negative in the fourth? Positive. All right. So we're looking at ka. What color is 11 pi over 6? Blue. So we're looking at our 30-degree triangle, 30-degree reference triangle. What is the adjacent leg on that triangle? Square root of 3 and the hypotenuse? 2. Okay. That's it. Hopefully pretty short and sweet today. Okay. So if you go ahead and you look on Haiku, there is a worksheet tonight. All right. We pretty much do a very similar lesson tomorrow. This was kind of the preview lesson to teach you how to use it. Okay, and then we kind of do it again because we want to make sure you understand how to use this really, really well. You need to bring that unit circle with you daily. Okay, that is your new best friend. Okay. All right. I will be around to stamp in 2 minutes. Okay? Francisco, you can go to the bathroom now.